As we keep moving on with our work in electricity and magnetism, this r hat vector is going to keep popping up and keep causing some confusion. So we thought we'd look at another aspect of the r hat vector and how you should interpret it. To date, very early in the course, you'll have two equations here involving electric field and force. Both have an r hat vector attached to the result there. In fact, it's this r hat vector sitting here that makes the whole vector quantities vectors themselves. The part in front of the r hat, in other words, this part right here and this part right here are the magnitudes of the vector. So this is the magnitude of the electric field. That's the magnitude of the force. But it's the r hat next to it that makes it into a vector, because as you know, electric field and forces are vectors. As you get to the second half of the course and you start talking about magnetism, there's another law here, which is the Savart Law, which we'll have a video on, which also involves an r hat vector. So in fact, it's buried right in here in something called the cross product. There's an r hat vector sitting right in there. So again, what this video is going to be about is just another interpretation about what do you do with this r hat vector, or what does it mean when you look at it at face value in equations like this. And the answer to the question of what it means in this sort of this face value look here, face value. You're just looking at it here. I mean, we're just looking at it here, we're just looking at it here, and we're looking at it here. That's what I mean by face value. What does it mean? And the answer to the question really is, what does it mean, is not much at this point. In other words, there isn't very much information you can sort of glean by just looking at the r hat vector as it sits in an equation like this. But what it means is you have to also often look deeper into the problem at hand to figure out what r hat might mean. That's the only way you're going to get a little more meaning out of r hat. So for instance, let's take the equation here for the electric field. So I'll just say, well, how is E, the electric field vector, related to r hat? Well, as you may know now, the reason why we have an r hat vector on the electric field in either case, is that we might have a positive charge here and a positive charge here. Or I guess instead of putting a positive charge here, let me just put an observation point right here. And what happened here is, in this particular case here, here's our observation point. There'll be an electric field line going in all directions because of the electric field due to the point charge. But if we're interested in this point down here, then in sort of a sense here, the r hat, this is our deeper look here, our r hat is going to be a line that's in the direction of this electric field vector. Suppose the observation point was over here. Then this would be our r hat vector over here. Suppose our electric field observation point was over here. Then this would be our r hat vector right here. R hat, that would be our r hat vector in there. So when you look at it like this here, the r hat vector in the electric field equation is really like a placeholder. It's sort of a placeholder that preserves or reminds you of the idea that you have to look a bit deeper into the problem to see exactly what r hat is going to mean. So in the case of this problem here, if we're talking about observing the electric field at this point, r hat would be down. At this point, r hat is up and to the left. At this point, r hat is down to the right. But I only got that by my deeper look into the problem to get more specifics. So when I mean here that when you look at r hat on this equation here, and at face value there isn't very much you can get out of it, that's actually true here. You have to look deeper into the problem to see exactly what it means. And when you look deeper here, oftentimes the r hat will reveal some needed direction. So back in the case of the electric field here, depending on what the problem is, r hat's either down to the left, down to the right, or up and to the left like that. Suppose we look at that force law now, the Coulomb's law here, which also has an r hat in it. Again, look at the equation right here. We clearly see the magnitude, and here's the direction part about it. Not much I can get face value, but just by looking at it. Okay, it's r hat. So what that should trigger in my mind then is I need to look at the problem and realize that for the force law, you can have a couple of charges, maybe these two right here, or maybe these two charges down here like this, or maybe a pair of negative charges that look like this and like this. What do I do about r hat in this case here? Well, if we're talking about a force law between these two charges here, r hat's going to be this vector right here. There's my r hat. For the positive and negative right here, there's my r hat. I guess those aren't the ones I meant to do, but for these negative charges here, there's an r hat right there. And just to sort of jazz up a little more and give you that direction, it looks like I just sort of skipped here. Suppose I had a negative charge here and a positive charge way down there. There's the two charges I have. In this case here, the r hat's going to be this line right here. There's going to be the r hat. So see, in the equation, face value, not much to get, just a placeholder. I have to look a bit deeper into the problem to see, well, what are the orientation of my charges? Because I know the force is always going to be between the two charges, and that's where the r hat is going to come from. So here, r hat may very well be along the x-axis. Here, it might be down and to the right, x-axis again, down and to the right. So no matter what the orientation of the charges are like this, no matter what the orientation is here, I have to look a bit deeper in here to finally see where my r hat's going to be. So that's what I mean by not much information. In the equation itself, just a placeholder to remind you to look at the equation, and there'll be some of these laws, some sort of adjoining line here between two objects. In this case, the charges here, they'll tell you exactly where that r hat vector is going to be. In the case of this magnetic field law right here, we also have to look deeper into that. Let me make a little room down here. We have to look a little bit deeper into that one as well. But what this law refers to, now whether you're on magnetism or not, it'll still be instructive to see another application of r hat here, is that what it tells you here is that you have a velocity vector which you cross into r hat. And there'll be another video that will discuss the cross product and what it means in here. But in a nutshell, what it means for the B field is that you'll have a charge like this, a charge q that's maybe moving this way with a speed v. So you can see those items in the equation here. These are just constants out front here. There's the charge, there's the velocity. But now it's asking you for an r hat. Now what is that going to be? Well, just like for the electric field, there's always an observation point at which you may be curious about what the electric field is here. There's an observation point in this law as well. So suppose that my observation point is going to be right here. So say I'm standing right here. Here's a little person. I'll just stand right here. And say this person wants to know what the magnetic field is right there at that point. Well, the r hat here, in this case here, is going to be the direction that connects the moving charge, the q that's moving some v, which is right here, with that observation point. So just like in all the other cases where there's always a line which I could label r hat, so too there's a line like this, and I can put a big r hat on that line as well. So there it is. There's your r hat in this particular case here. So in this case here, my deeper look revealed that my r hat, in this case, connects the charge and observation point. That's what r hat's job is in this particular equation right here, to make that connection. So see, you can't really get that, but get the true meaning for r hat just by looking at the equation. It's a very general equation that works, but you have to make at least a small adaptation to your problem in order to understand what that r hat may be. And then once you know what r hat is, connecting the charge and this observation point right here, then r squared, this r squared down here, also becomes something you can identify, because r squared, if this is going to be r, that's the physical distance now between the charge and the observation point. Of course, you can just square that to get r squared. So that's what we mean by, having to look a bit deep into your problem to get r hat. In another case, let's maybe look at one more example of that moving charge. Here's a moving charge here, which might be going over here like this. And maybe I'm interested in the magnetic field way over here, something like that. Where is r hat now? Well, the Savart Law says use this law. There's r hat. And in this case here, the adaptation of the equation says that r hat connects the position of the charge and the observation point. So there's the r hat right there. And of course, the length of this vector here is r, and from that you can get r squared, and you're well on your way to adapting that equation to whatever uses you need. So that's sort of our little bit on r hat here. Just a few summary terms right here. Again, I'm just going to stick to the point that the face value r hat here doesn't mean much. Not much meaning there. But it has a use. Or it has a role in each equation. And for you to successfully use an equation that involves an r hat, you sort of have to identify what role does that r hat play. So in the electric field, r hat, it connects the charge and your observation point. That's the role r hat plays in the electric field equation. In the Coulomb's law, r hat here connects the two charges together. And in the Savart Law, the r hat is very much like the role it plays in the electric field equation. It connects the charge and your observation point. So see, the r hats all have different roles. So I'll say it also doesn't just have one meaning at all. So you can't say, oh, it's r hat, it means this. That's not true. It depends on the equation. depends on the equation that it's used in. So r hat pops up all over science, all over physics. And just remember maybe these points here. Face value means nothing. It has a role in each equation, and learning about that role is part of your steps in learning about the equation. And we see three different uses of r hat between E, F, and B, although r hat plays a similar role between B and E. So it doesn't have just one meaning. It depends on the equation that it's in. So part of your learning process about the equation. Anyway, there's a little more information about r hat for you.